Alright, so here is your introduction video for section 4.1. Chapter 4, we talk about quadratic functions. Quadratic functions, what they look like, maybe you have seen this a little bit in Algebra 1 just as an introduction, is a graph that has this shape. We call this a parabola. And any equation where you have an x squared and that 2 is the highest exponent with x is going to be a quadratic function. In these notes, you are going to learn about standard form for a quadratic function. In 4.2, you learn about two other forms, intercept and vertex form. So kind of like, your linear equations have point, slope, slope, intercept, and standard form. Quadratic functions, you can write the equation in three different ways also. So here's that parent function for a quadratic graph. You can see the parabolic shape. And if you just have y equals x squared with no extra numbers, your vertex, what we call the vertex, will be at the origin at 0, 0. And then we have something called an axis of symmetry. These graphs will be symmetrical every single time, so the axis of symmetry just goes through the center of your parabola like that. It'll always be an equation of the form x equals some number. Well, for this parent function right there, it would just be x equals 0. And the vertex, you could identify that as an ordered pair 0, 0. Alright, so here's what standard form actually looks like. We have y equals ax squared plus bx plus c, where your a, b, and c will be filled in with some numbers. For example, maybe it's y equals 2x squared plus 3x plus 1, where this 2 would be the a, the 3 would be the b, and this 1 on the end would be the c value. You're going to have a way to find the vertex in standard form. And what you do is you start by finding the x-coordinate. So the x-coordinate has this equation, negative b over 2a. So anytime that you go to graph standard form quadratics, you have to first find the vertex, and you know that x is equal to a negative b over 2a, and you'll pull your b value and your a value from standard form. We'll be able to tell if this graph opens up or down based on this a value out front with the x squared. If it's positive, where a is greater than 0, then we know that it's going to open up. It'll look something like that. If it's negative, where a is less than 0, then our graph will open down. So you'll have an idea of what to expect your graph to look like simply based on that a value. Sometimes we're asked to put quadratic equations into standard form. If this shows up in the homework, all you have to do is basically multiply everything out and combine your like terms. For example, here we have y equals x plus 5 times x plus 2. If we go ahead and FOIL this, what we'll end up with is x squared plus 2x plus 5x plus 10, or combining like terms, y equals x squared plus 7x plus 10. And now it looks like that standard form, where our a value is in front of our x squared, that would be a 1, our b value is 7, and our c value is 10. So from here we could find the vertex to graph and all that good stuff. So there's another concept video for how to graph a quadratic in standard form. So I just wanted to give you a heads up for the things that we do when we graph. First thing you have to do is find the vertex, and when this is standard form, you'll start by that equation, y equals negative b over 2a. By the way, you do have to memorize that. It will not be given to you on quizzes or tests. Once you get the x value, then you'll have to plug it in for your x's to get the y, so you have that ordered pair xy for the vertex. We also find a y-intercept. That's helpful just to make sure that our points are all lining up. And you guys know how to find a y-intercept. You plug 0 in for x, and that will just give you another point on your graph. Axis of symmetry is always going to be x equals some number, and then you can tell if it's opening up or down from the from the original equation up there, well, if we know that our a value is in front of the x squared, so our a value must be a 1, which is positive, so I know this graph is opening up. And then what's nice about quadratics is we get the rest of the points by doing a pattern of change. And so you'll see that in the video where you take your a value and you multiply it by a 1, a 3, and a 5, and that's going to give you your pattern for where to plot the rest of the points. But you'll want to go ahead and watch that video just to see the details, but there's your heads up on what we have to do when we're asked to graph a quadratic function. When we deal with quadratics, here we have 3 parabolas graphed on 3 different graphs. Sometimes we have to figure out if the graphs have a maximum or minimum. And so a maximum or minimum, what that deals with is, you know, what's the highest point or the lowest point. So it's kind of an up and down measurement like this versus a side to side. We want to know what the highest point on the graph is and what the lowest point on the graph is, or what the lowest point on the graph is. So in this first example, we can see that we have this lowest point right here. Your vertex will always be part of your max or min value. So if I look at what that ordered pair is, it's a -1, -2. Kind of hard to see. So this graph has a minimum because it has that lowest point, everything's above it. And the minimum value, all that we need is the the y value, because that's the up and down measurement. So I know that the minimum value is -2 on this graph. If we look at the second graph, see how your vertex, everything is below it, so it has a highest point, which means that's a maximum. And then you want to look at your vertex value, it's 1, 0, and the maximum value is just the y value of 0. This next graph, you've got your lowest point, so that will be a minimum, and again, just the y value from your vertex. Our vertex is 1, -3, so the minimum value is -3. Don't give both the x and the y for the min or max, just the y value. And that's basically what 4.1 is about. Go ahead and watch the concept videos just to get more details on these ideas, but that's what quadratics look like.